Today I'm going to show you how to solve for simple addition statements using Cuisenaire rods. This is a first grade lesson. We have two objectives. The first is to identify the value of each rod. The second is to solve simple addition statements for values at and below 10 and values at and below 20. The Common Core standard covered in this lesson is under the Operations and Algebraic Thinking domain. It is standard 1.6. I'm going to focus on the addition aspect of the first part of this standard, which reads, add and subtract within 20, demonstrating fluency for addition and subtraction within 10. The following is a list of academic language covered in this lesson. This list includes value, addition, plus, addends, solve, and equals. Students will study and use the academic language by examining and comparing the value of each rod through a sequential staircase. Students will also examine, evaluate, and solve simple addition problems by using the rods. So let's begin our lesson. What is the value of each rod? In order to create and solve for simple addition statements using the Cuisenaire rods, we first have to determine the value of each rod. The Cuisenaire rods represent the numbers 1 through 10, so one rod, or color, represents one number. So let's try to find out what each value is. Let's start at the bottom, so the smallest number. 1 is represented by the white rod. Each rod that follows will be increased by 1, or added to. 2 is the red rod. When we add one more, we get the light green rod, which represents 3. If we continue this, purple will be 4, yellow is 5, dark green is 6, black is 7, brown is 8, blue is 9, and orange is 10. These values cover the numbers 1 through 10, and each time the rod is increased in length by 1. So we first have the number 1, 2, 3, and all the way up to 10. So how do we add using the Cuisenaire rods? Let's start with a simple addition statement. Also, if you notice, I added the staircase up here in the corner so that we can be reminded of the value of each rod. So let's use a simple addition statement. 2 plus 3. Now I'm sure you all know the answer, but let's use the rods to try to find the answer. So let's look at our problem and examine how we want to do this. We have two addends. The first is 2 and the second is 3. We want to combine these two addends to get a total. So let's use the Cuisenaire rods to create a statement or to represent this statement. So let's start with the number 2, our first addend. So the red rod represents the number 2. Let's pick the number 3, which is the light green rod. We're going to put them side by side in order to represent this statement here. So we have 2 plus 3. Now we all know that the answer is 5. So in order to double check that we know that this answer is 5, we're going to take the 5 rod and place it alongside the 2 and the 3 and see if they have an equal length. So now we can see that 2 plus 3 is equal to 5. It is the same length. And if you notice, when you place the rods side by side in this way, it creates an equal sign. So the answer to our question of 2 plus 3 is equal to 5. And remember that 2 plus 3 equals 5 can also be written in this way. Both of these statements are correct. They're just two different ways of writing it, and they both can be represented in the same way using this Cuisenaire rod setup. So let's try another example. Let's do 6 plus 4. Now, we're going to start this problem the same way as we started our last problem. So let's start with our first add-in. Our first add-in is 6, or the dark green rod. The second add-in is 4, or the purple rod. So we're going to place these side by side to show 6 plus 4. Now this one is a little bit harder of a problem to solve. So let's make an educated guess as to what we think that the problem is, or the answer is. So we know that the answer is bigger than 6 because we're adding 4 to 6. So I'm going to guess that the answer is 9. And in order to see if we're right, we're going to take the 9 rod and place it alongside the 6 plus 4 rods. When we do this, we can see that the 9 rod is too short. It doesn't line up. It is not equal. So we know that 6 plus 4 does not equal 9. But when we do this, we can look and see the space we have left. And we know that the space we have left is big enough for the 1 rod. So we now know that a 9 and a 1 is the same length as a 6 and a 4. And 9 plus 1 is equal to 10. So 6 plus 4 must be equal to 10. In order to check this and see if 6 plus 4 is equal to 10, we can take the 10 rod and line it up with our 2 rods that we have. So now we can see that 6 plus 4 is equal to 10. And by guessing and checking, we also found out that 9 plus 1 is equal to 10. And remember, like the problem before, this is also a correct way to write 6 plus 4 is equal to 10. So both statements, either way that we write them, can be represented the same way using the rods. But how do we represent sums that are over 10? In other words, when we have an addition statement like 7 plus 8, in which we can guess that our answer is going to be more than 10, how can we use the Cuisenaire rods to create a statement and to check for our answer? Well, let's begin like we did before. We'll look at our add-ins and use those numbers to create a statement or a train. So 7, which is the black rod, and 8, which is the brown rod, can form a train and represent 7 plus 8. When we go to solve or check for our answer, we'll use the 10 rod as a starting point because we know that our answer is going to be more than 10. So when you place the 10 rod next to the 7 and the 8 rod, you can see that they don't match. They are not equal in length. In fact, we need another rod or a combination of rods to fill in the space and get our answer. So I'm going to guess that the yellow rod will fit into that space and that we'll have 2 equal lengths. Let's see if I'm right. The yellow rod does fit into that space. So now I can see that yellow, which is 5, and orange, which is 10, is the same length as 7, which is black, and 8, which is brown. Well, I know that 10 plus 5 is equal to 15. And because those 2 rods are the same as the 7 and the 8 rod, 7 plus 8 must also equal 15. And don't forget that 7 plus 8 can be written in this fashion, so that this representation, or this way to write the statement, and this way to write the statement, are both represented here using the Cuisenaire rods. Now it's your turn. I want you to turn to your partner, take out your set of Cuisenaire rods, and solve for these equations. If you forget what each rod is valued at, I put the staircase here. And to remind you, the white is 1, red is 2, light green is 3, purple is 4, yellow is 5, dark green is 6, black is 7, brown is 8, blue is 9, and orange is 10.